Good, beautiful day to all of you grade 11s. Hopefully, we'll have grade 11s in here. Okay. And the hope is that we'll have grade 11s that actually want to make sure that they are getting their maths in the right place. You see? Yeah. We're gonna do some revision, and we are going to solve some exponential equations and simplify some exponential expressions. So hopefully you guys are up for it, up for that. Okay. Yeah. All my beloved grade 11s up in the house, up in the hizzles. Welcome, welcome, welcome. All right. This is a freestyle live. It is a freestyle live. If you are here, I would appreciate your participation, your commentary, your anything. All right. Your anything. Please feel free to participate as you feel fit and feel free. Okay. So I think let's start it up at the top. Let's start it up at the top. Let's start it up at the door. Okay. I think since it's been week 1, we have done a revision for, well, we've done exponents, exponential expressions, I'm hoping. Yeah. I think someone just joined the live. Be happy for you to make yourself known if you can, whoever you are. If at all possible, that would be great. Yeah, we are up here live streaming, up in here, up in here, up in here. So let's check out yes, I am live. So I'm just going to revise exponents. Okay, we are going to revise exponents, grade 11, because at our respective schools by now, as it is 2026, we should be done with exponents by now, and I'm sure we've moved on to other things. So let's just revise again the laws of exponents. Hello, Jorge. Just revise the exponents, the laws, and everything that there is attached to that. Law number 1 of exponents. Yeah, please guys, if you can and if you want and if it's possible, share this out to as many grade 11 people as you possibly can. It would be great. All right. Yeah, I'm just wanting to get into this YouTube thing because hey, TikTok is not TikToking, whereas YouTube is YouTubing. All right, and I do want to get to a place where we can start. Yeah, so we are just gonna revise exponents and revise everything that there is. Law number 1, a to the power m times a to the power n. When we are multiplying same bases, we add the exponents. I think we know that by now. When we are dividing same bases with exponents, we subtract the exponents. A to the power m raised to the power n, we know that we multiply the exponents. AB to the power m. When there's a multiplication relationship between different bases, we know that we distribute the exponent by multiplication to each respective exponent for each base, but that only applies where the bases are multiplied, and it also applies where the bases are divided. We multiply the exponents, we distribute the exponent and multiply it with whatever exponent is there. That applies for division and multiplication. Never does it apply for addition and subtraction between bases. So we must be clear about that and never make such a mistake. A to the power 0, any base raised to the power 0 is equal to 1. Then negative exponents, any base raised to a negative exponent is equal to whatever the coefficient is there gets left behind in the numerator. The base goes to the denominator and the exponent that is negative becomes positive. Okay, so let's never forget that. Okay, any base raised to a negative exponent, the base goes to the denominator because it was currently in the numerator. The coefficient gets left behind because it's leaving the numerator. Coefficient gets left behind, the base goes to the denominator, the exponent changes from negative to what? To positive. Right. And then this has direct application for situations such as this, where a over b is raised to the power negative n. We simply change the numerator and the denominator, and then the exponent becomes positive, and then we apply this law to then distribute the exponent b to the power n, a to the power n, because the relationship between the bases is one of division. So these are important basic laws that we need to know for exponents. All right. Yeah. All right. Yeah. Very important. It's a matter of life and death that you must be one that is well versed with these fundamental laws. Okay. Yeah. Just a few things to note here, just with this, the base raised to the power 0. If you have a negative a to the power 0, for instance, this, okay, will be equal to negative 1. The reason why it's equal to negative 1, it's only the a that is raised to the power 0. The negative 1 is multiplied to a to the power 0. So the a gets affected, it becomes 1. The sign stays the same, it's negative 1. Different story though if we had negative a all raised to the power 0. Because if you're applying an even exponent to a negative sign, it becomes positive. All right? Even exponent to a negative sign becomes positive, and then a to the power 0 is actually positive 1. Okay, so just take note of that. We must always check if where is the exponent being applied. Okay. Okay, so I hope that makes sense, and those are the laws that we need to know. So let's look at some problems. Take it one step at a time, and we are going to just apply our laws nice and slowly. We have 15x to the power 4y to the power 6 times 2y squared x to the power 0. What is basically the outcome? So what we can see here is we have one term. All right, it's very important to establish how many terms. Then after that, you multiply 15x to the power 4y to the power 6 times y to the power 2 times x to the power 0. So this is clear multiplication. So multiplication, we are going to look at multiplying the sign, the number, and the letter. Positive times a positive is a positive. 15 times 2, that is 30. X to the power 4 times x to the power 0, that gives us x to the power 4 plus 0. And then y to the power 6 times y squared is y to the power 6 plus 2. Final answer, 30x to the power 4y to the power 8. Okay, I think that's fine. That multiplication, simple, straightforward, didn't even move a cinch. 3 marks we get very easily. 1 mark for the coefficient, the sign with its number. 1 mark for the variable x to the power 4. You added the exponents because the bases were the same. And then you added the exponents for y. The bases are the same because you were multiplying. Let's look at another one. 1.2. 3x to the power 3 over 27x to the power 9 multiplied by 3x to the power 3. So once again, when we look at this problem, what do we see? Relationship of division together with multiplication. No plus or minus sign. So that means our law number 1 and law number 2 can be applied nicely and freely. So we can look at the division, because remember, we are working with bed mass here, board mass. Brackets, order, your squares and your roots. D, division. M, multiplication. A, addition. S, subtraction. So let's first divide. Sign, number, letter. Positive divided by positive is positive. 3 divided by 27. 3 goes into 27 how many times? 3 goes into 3 once. 3 goes into 27 9 times. Okay. Then after the number, we go to the letter. X to the power 3 minus 9. Bases are the same. You are dividing. You keep the variable exponent at the numerator. You subtract the exponent. Multiplied by, now here we have 3x to the power 3. That's application of law, this law. Bases raised to an exponent. If the relationship is multiply, you can distribute the exponent by multiplication. So we can do that here. It's going to be 3 to the power 3, x to the power 3. So far so good. We have 1 over 9. 3 minus 9 is x to the power negative 6 times 27x to the power 3. Now we have two things that we need to multiply. Positive times positive will give us a positive sign. 1 over 9 times 27. Okay, 9 goes into 27 how many times, guys? 3. So we have 3x. Then we multiply the variables. When you're multiplying the variables, we keep the variable, we add the exponents. Negative 6 plus 3. What is the final answer? 3x to the power negative 3. But then remember, our answers cannot be written as negative exponents. So what do? This negative exponent goes to the denominator. It becomes x raised to the power positive 3. That is our final answer. Okay, that was nice and simple. We worked on the division. We got 3 divided by 27. 3 goes into 3 once. 3 goes into 27 9 times. The reason why we are saying how many times does 3 go into 3 is because our numerical base, 3 and 27, there's a highest common factor between 3 and 27. 3 goes into 3 times, 3 goes into 27 9 times. Or if you wanted to, you could have changed 27 to 3 to the power 3. And then you would have said 3 to the power 1 minus 3 to the power 3, which would have given you 3 to the power negative t, which is 1 over 9. Still the same thing. At the end of the day, we'd still have gotten the same answer. Okay? Nice and smooth. Let's look at problem number 3. So guys, as long as there's multiply and divide in a problem, it becomes very easy to just apply law number 1 and law number 2 in problems like that. So it's very nice. Number 3. 4x to the power 3, y to the power 5 over 12x to the power 9, y to the power 0. So you guys can go ahead and do this. Of course, as I am doing it, you can do it yourself and quickly sort of like check your own skills, check how effective you are in simplifying. All right, so we're looking at multiplication at the top, multiplication at the bottom, and division. And with board mass, we know division and multiplication. Division comes before multiplication, DMAS. So we can divide first. Divide sign, divide number, divide letter. What's 4 divided by 12? Positive divided by positive is positive. 4 divided by 12. That means the highest common factor between 4 and 12. 4 goes into 4 how many times? Once. Whereas 4 goes into 12 how many times? 3 times. Then you say x to the power 3 divided by x to the power 9. It's x to the power 3 in the numerator minus 9. Okay. Y in the numerator, y to the power 5 minus 0. Finally, get an answer of 1 over 3, x to the power negative 6, y to the power 5. These are all in the numerator. So our final answer is going to be 1y to the power 5. The 1y to the power 5, that stays in the numerator. The x to the power negative 6 changes to become x to the power positive 6 with a 3 before the x. So we get a final answer of 1y to the power 5 over 3x to the power 6. Okay, we're moving on very nicely. Let's move on to our next problem. 2 to the power 13 times 2 to the power 14 over 2 to the power 25 minus 2 to the power 0. Let's simplify again. Number 4 says, since Monday, how did we get 30? Where was the 30, my dear? 4x to the power 3, y to the power 5 over 12x to the power 9, y to the power 0. We are dividing 4 divided by 12. 4 goes into 4 once, 4 goes into 12 3 times. X to the power 3 divided by x to the power 9, that's x to the power 3 minus 9 there in the numerator. Okay, the x is there in the numerator because we are subtracting the 9 from the numerator. 3 minus 9. When we are dividing bases, we subtract exponents. Y to the power 5 minus 0 in the numerator. Then we get 1. This 1 over 3 is what we got most. X to the power negative 6 still in the numerator. 3 minus 9 is negative 6. Y to the power 5. 5 minus 0 is 5 in the numerator. The 1 is in the numerator. The y to the power 5 stays there in the numerator because it has a positive exponent. It's what we got after saying 5 minus 0. Y to the power 5. The x to the power negative 6 moves to the denominator. So we now have 1y to the power 5. That 1 was there. This is 3x. This x to the power not negative 6 anymore, but x to the power positive 6. Because remember, when you have a base raised to a negative exponent, the base moves to the denominator. The exponent that is negative changes from negative to positive. So we have 3x to the power 6 in the numerator. Okay, it's not 30, it's 3x to the power 6. I hope that clarifies what you thought I had written. Okay, let's move on. 2 to the power 13 times 2 to the power 14 over 2 to the power 25 minus 2 to the power 0. So we have a relationship here of multiplication and division. Minus 2 to the power 0. So when we look at BODMAS, we know BODMAS says brackets first, then order, meaning the exponents and roots. Division next. So division and multiplication. We can sort out the division and the multiplication. After we get the answer here, then we can subtract this 2 to the power 0. So let's sort out this. These are all bases, base 2 times base 2 times divided by another base 2 to the power 25. So this we can apply the law. 2 to the power 13 plus 14 in the numerator. Then this 2 to the power 25. When we are dividing, what do we do to the exponents? We subtract. So we can have 2 to the power 13, that's 13, plus 14. Then this 2 to the power 25. Since the bases are the same and we are dividing, what do we do to the exponents for same bases? We can change the 25 to subtraction and it can join our exponents there that we are adding. Hope that's clear. Then it's minus 2 to the power 0, that gives us 1. Then what's 2 to the power 13 plus 14? That gives us 27. What's 27 minus 52? That gives us 2. Final answer, 2 to the power 2 is 4. 4 minus 1 gives you 3. So all in all, we have a beautiful working out here where we saw that through BODMAS, we can start with the multiplication and division. And later on, when we have simplified our multiplication and division, where we can see law number 1 and 2 can be applied, 2 to the power 13 plus 14 minus 25. We keep the bases 2. We add the exponents in the numerator. We subtract the exponent for the base in the denominator. Then we get 2 to the power 2. Minus what? What's 2 to the power 0? Any base to the power 0 is 1. So 2 squared is 4. 4 minus 1 is 3. And that's our final answer. Very nicely done. No problem. So you see, when there's multiply and divide, it's so easy to just move. Let's look at the next question. 2x squared to the power 4, x to the power 4, brackets to the power 3, minus 2x to the power 3 x squared over 16x to the power 4 to the power 5. Simplify again. The question says using the law of exponents. So we look at the numerator. How many terms do we see in the numerator? It's all 1. Because there's 2, there's a bracket, there's a bracket, there's a bracket. In the denominator, there's also 1 term. And we can clearly see that for 2, the x squared is raised to the power 4. It's only the x squared that's raised to the power 4. So we can write down the 2. Then the x squared raised to the power 4, we can apply law number 3. We multiply the exponent. So here we can say x to the power, what's 2 times 4? 8. There's a bracket. Brackets mean multiply. Okay, what's x to the power 4 times 3? That's x to the power 12. All right, makes sense? X to the power 12. So 2, x to the power 2 times 4 is x to the power 8. Okay, because we are dealing with the bracket raised to an exponent. That's the application of law number 3. X to the power 4 raised to the power 3, that's x to the power 4 times 3, which is 12. Brackets minus 2x to the power 3 raised to the power 2. Now this exponent is outside this entire bracket. So what do? We apply the exponent to the sign, to the number, to the letter. We don't apply the exponent just to the letter. We apply the exponent first to the sign. Now we know that any even exponent that is applied to a negative sign becomes positive. Any even exponent applied to a negative sign becomes positive. So if we apply this even to exponent to this negative sign, it becomes positive. That's the sign taken care of. We apply this exponent 2 to the 2. What's 2 to the power 2? We get 4. Remember, brackets mean multiply. We apply this exponent 2 to the 3. This is 3 times 2. That gives us x to the power 6. All over. 16 is outside. It's not affected by the exponent 5. X to the power 4 is affected by the exponent 5. I repeat, x to the power 4 is influenced by the x to the power 5. So we multiply the 4 and the 5. This becomes x to the power 20. So far, we have resolved all the brackets that we had there. Okay, one more time. 2 not affected. X squared affected by the exponent 4. 2 times 4 is 8. The brackets mean multiply between these two. So x to the power 4 raised to the power 3. 4 times 3, 12. Brackets minus 2x to the power 3. All of that is inside the bracket, and there's an even exponent on the outside. You apply that even exponent to the negative sign, it becomes positive. Because I said, whenever you apply an even exponent to a negative sign, what happens to the sign? It becomes positive. Then you apply the even exponent to the number. 2 squared is 4. You apply the even exponent to the letter variable. 3 times 2 is 6. So you have just now found 2x to the power 8 times x to the power 12 times 4x to the power 6 over what? 16x to the power 20. So let's now go ahead, guys, and multiply what's in the numerator. 2 times 1 times 4. There's a 1 here. 2 times 1 times 4. Remember, when we multiply, we are multiplying the sign, the number, and the letter. These are all positive. That will give me a positive answer. Number 2 times 1 times 4. That gives you 8. X to the power 8 times x to the power 12 times x to the power 6. Bases are the same. We are multiplying. What do we do to the exponents when the bases are the same and we are multiplying? We add the exponents. What's 8 plus 12? It's 20. What's 20 plus 6? 26. All over 16x to the power 20. I think now we can simplify what's left, top and bottom. Multiply, we can divide now. Sign, number, letter. Positive divided by positive, positive. Number, 8 divided by 16. 8 goes into 8 once. 8 goes into 16 2 times. Then x to the power 26 divided by x to the power 20. That's x to the power 26 minus the 20 in the numerator. Because remember, when you are dividing same bases, you keep the base, you subtract the exponents. So whatever the sign of the denominator exponent was, it changes the minute you move it to the numerator. Final answer, x to the power 6 over 2. Done. All right. This so far is all simplification questions that involve multiplication and division only. All right. Yeah. So it's nice. It's so nice when you do questions like that. Number 6. Let's go. Hopefully you're going nicely so far. And as I am doing it, hopefully you are also doing it. But more than anything else, you are seeing what should be done when you have multiplication and division of numerical bases. Okay, 27 to the power x times 9 to the power x plus 1 over 3 to the power 5x plus 3. 27, 9, 3. Variable bases, your bases. So what does that mean? First step is that you change all composite bases to prime bases. Composite to prime. 27 is a composite number because it has more than 2 factors. You want to change 27 to a prime base number. So what is 27 when you write it as a prime base number? 27 can be written as 3 to the power 3. You put it in brackets, you hang the exponent as it was outside. Times, you go to 9. What is 9 as a prime base number? Guys, remember you can always find all of these using your calculator. If you go to your calculator and you press 27 is equal to shift fact, you'll get to 3 to the power 3. You go to a scientific calculator, you press 9 is equal to shift fact, you will get 3 to the power 2. You put it in brackets, you place your expression of x plus 1 outside. Over 3 to the power 5x plus 3, that's already prime base, so the exponent is fine. Now we apply law number 3. Any base raised to an exponent with another one outside, you multiply. So now we have 3 to the power 3x times 3, you distribute the 2 to the x, you distribute the 2 to the 1, 2x plus 2 over 3 to the power 5x plus 3. Please guys, don't forget to distribute the 2 to the x. 2 times x is 2x. 2 times 1. The common mistake learners make is not distributing the number to both the terms outside the bracket. That's why I insist, change 9 to base exponent, and then please guys, put what you change from composite to prime, put it in brackets. so that you can remember to distribute the exponent after you are done. Now we have nice prime bases for all three bases. So now we can just apply law number 1 and 2. At the top, we have 3 to the power 3x. When you are multiplying, the bases are the same. You keep the base, you add. So you are going to say plus 2x plus 2. Right? This is also base 3. Remember, when you are dividing, you are now going to be subtracting. You change the sign. If it's going to be subtraction, remember, if you are going to be subtracting 5x plus 3, remember this negative needs to go into the 5x and the negative needs to go into the 3x. So you get negative 5x minus 3. So that's why I basically say to the learners, the base 3 to the power 5x plus 3. Remember, you said 3 to the power 3x times 3 to the power 2x plus 2. What did you do? You kept the base 3, you added these exponents. But what's coming from below? It means 5x, you look at the sign, what is it? It's positive. So that means you are going to write a negative 5x there at the top. Look at the 3, it's what? Positive, which means the sign is also going to change. You are going to write a negative 3 at the top. When you fail to do that, guys, that's where things really seriously start to go wrong. So let's add now. What's 3x plus 2x? It's 5x minus another 5x. That gives you 0. Then what's 2 minus 3? You get negative 1. Remember, 0 minus 1 is negative 1. Final answer, 3 to the power negative 1 is simply going to be 1 over 3. When a base is raised to a negative number, you move that number base to the denominator. It is currently in the numerator. You basically change the position of where the base is if it has a negative exponent. If it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator. So in this case, the base is in the numerator. It raised to a negative exponent, you move the base 3 to the denominator. The exponent sign changes from negative to positive. So you have 3 to the power 1. The 1 is not seen. Then what gets left behind? The 1 that is multiplied to the 3 to the power negative 1. That's what you see here. This is the final answer. This is how you simplify this. Not too shabby, hey Nige? So we change composite bases to prime. And we use brackets when we change. Please, guys. Why? So that we don't forget to distribute the exponent. And then we keep base, we add exponents. When you go down, signs of the exponents, they change. 5x is negative 5x, 3x, negative 3x, when you bring these up to the numerator. Then we add and subtract like terms. So important to not butcher this step. You add and subtract like terms. 3x and 2x are like terms because the variables are the same, and it's a like term to negative 5x. You get 0 there. Then 2 minus 3 is negative 1. Then you can write this as a positive exponent by 1 over 3, and that basically is that. Okay, are we good? Yeah, I hope we will. Guys, if you have any questions about anything, I'm relying on you to ask. Okay, this is the first problem I did. Number 1, very straightforward, a multiplication problem where you just multiply the signs, you multiply the numbers, you multiply the letters. 15 times 2 is 30. X to the power 4 times x to the power 0, x to the power 4 plus 0, you get 4. And then y to the power 6 times y to the power 2, you add 6 plus 2 as an exponent whilst keeping the variable, you get y to the power 8. That's the answer. Again, you have a fraction, meaning division. You are multiplying 3x to the power 3. So you divide. 3 divided by 27 is 1 over 9. 3 goes into 3 once, 3 goes into 27 9 times. You divide the variable bases, you keep the base, you subtract the exponent, 3 minus 9, x to the power negative 6. You distribute the exponent 3 because this is 3x. You distribute it to the 3, you distribute it to the x, you get 27x to the power 3. You multiply these two. Multiply the sign, positive times a positive is positive. 1 over 9 times 27 is 3. Then you multiply the letter. X to the power minus 6 times x to the power 3. It means you keep the variable, you add the exponents. Minus 6 plus 3 gives you negative 3. But remember, we don't leave an answer with a negative exponent. So that means 3 remains. X goes to the denominator. Its exponent changes from negative to positive. Final answer is 3 over x to the power 3. And we did this one as well. Division, clear division. 4 divided by 12, 1 over 3. Same base division, you subtract the exponents. Same base division, you subtract the exponents. X to the power negative 6 in the numerator, y to the power 5 in the numerator. But remember, this needs to go to the denominator. The exponent changes to positive. You're left with 1y to the power 5 in the numerator over 3 x to the power, not negative anymore, but positive. Okay, so guys, it's just flowing, man. Multiply, divide, keep the base. All the bases are the same here. So we are adding, we are subtracting. There it is. We get 2 to the power 2. That's minus 2 to the power 0 is 1. So here we get 2 to the power 2, which is 4. 4 minus 1 is 3. Straightforward. Here, all multiply at the top and one term at the bottom. So it's one term at the top, one term at the bottom. Apply exponential laws. 2 is 2, it's alone. X to the power 2 is raised to 4, it's x to the power 8. X to the power 4 is raised to the power 3, x to the power 12. You apply the exponent that is even to a negative sign, becomes positive. Apply the exponent that is even to 2, 2 squared is 4. Apply the exponent that is 2 to x to the power 3. That's the multiplication of 2 times 3, which is 6. Bottom, you have 16. You multiply x to the power 4 times to the power 5. That gives you x to the power 20. You multiply what's in the top. How? Sign, number, letter. Positive times a positive times positive is positive. 2 times 1 times 4 is 8. That's the number. Then the letter x to the power 8 times x to the power 12 times x to the power 6. You are adding the exponents. 8 plus 12 plus 6. That gives you 26. Over 16x to the power 20. You divide the sign. Positive times a positive is positive. 8 divided by 16. You get a half. 8 goes into 8 once, 8 goes into 16 twice, because 8 and 16, the highest common factor is 8. Then you have x to the power 26. You are dividing these bases, they are the same. You subtract 26 minus 20, you get x to the power 6 over 2. That's the final answer, simplified and sweet. Then I just did this one. You guys saw it. You were witnesses. Straightforward. Okay, guys, we're moving nicely. And the exponents are exponenting. Woo! Isn't that great? Next question. 3x to the power 4, all raised to the power 3, plus 2x to the power 3, all raised to the power 4, all over 81 times 3 to the power negative 4 times x to the power 7. So what we see now is that in the numerator, we are asked to simplify again. If we look at the numerator, how many terms do we have? 1, 2 terms. Look at the denominator, how many terms do we have? Well, if the relationship is multiply, it means multiply combines everything. So this is one term. Okay. So let's deal with the brackets, because board math says such. So 3x to the power 4 raised to the power 3, this exponent, since the relationship inside is one of multiplication and this is one term, it means you can apply the exponent to the sign. If it was there, it's positive, the number which is there, and the letter that is there. So let's do that for each bracket, this one and that one. We're going to apply 3 here to everything, apply 4 to everything inside, because of the multiplication relationship that's there. So an odd exponent, okay. Heli Nati Benya. No, I'm glad. I understand better than my teacher. Okay, no, it's fine. I'm happy. If you apply the exponent 3 to the positive sign, apply the exponent 3 to the positive sign, an odd number applied to a positive sign is positive. So that's the sign. Apply the exponent to the 3. That gives us 3 to the power 3. Remember, there's an exponent 1 here. So 1 times 3 gives you 3. That's why you get 3 to the power 3. Then x to the power 4, we apply the exponent to the letter. It's x to the power, what's 4 times 3? We get 12. So we have 3 to the power 3 x to the power 12. Let's move on to the other bracket. 2x to the power 3 to the power 4. We apply the exponent because it's one term. You apply that exponent to the sign. An even exponent applied to a positive sign remains positive. Then we have 2. We apply the exponent 4 to the number 2 to the power 4. We apply the exponent to the letter. It's x to the power what? 3 times 4. That gives you 12. All over. Now, let's see what we have here. This is 81 times 3 to the power negative 4 is 1 over 3 to the power 4. Because you can rewrite a base raised to an exponent that is negative to become 1 over that base raised to a positive exponent. And then we have x to the power 7 here. Let's continue. We'll get back to everything else. What's 3 to the power 3? That's 27. X to the power 12 plus. What's 2 to the power 4? 16x to the power 12. All over 81. You multiply with 1 over 3 to the power 4. That is 81 times 1 over 81 times x to the power 7. Guys, you might notice something there in the numerator. Before we go anywhere else, in the numerator, I'm sure you can see something interesting. Remember, here in the numerator, we are adding. But what do you notice here? We have what we call like terms. And we know that like terms, according to our basic understanding, we can add and subtract like terms. How? We keep that exponent, that variable, x to the power 12 as it is, because it is like uniform. Like terms are like uniform. I usually say that to my learners. Like terms are like kids that wear the same uniform. Okay, what if you have kids that wear the same uniform and they go to Botlobotadzi High School? Then you can count the number of learners that go to Botlobotadzi High School. We could say 27 learners of Botlobotadzi plus 16 learners of Botlobotadzi equals to how many learners of what? Botlobotadzi. So this does not change. You keep the variable with its exponent, because the variable with the same exponent means that these are like terms. Since we are adding, then we add the numbers. What's 27 plus 16? You see, I hope you understand. Okay, that will give you what? 27 plus 16 will give you 43 over 81 times 1 over 81. That is 1. Okay, so now what you are left with is 43x to the power 12 over 1x to the power 7. The relationship that now exists between 43x to the power 12 divided by 1x to the power 7 is one of division. So when we divide, guys, and there's one term at the top and the bottom, it's very simple what we do. We simply divide the sign. Positive divided by positive gives us a positive. We divide the number. 43 divided by 1 is 43. We divide the letter L. X to the power 12 divided by x to the power 7 gives us x to the power 12 minus 7. Final answer, 43x. 12 minus 7, guys, gives us 5. We are done. Okay, straightforward, no hiccups, just nice and beautiful. No crying, no woman, no cry. All right. Okay, very nice, guys. See, just to recap again, 3x to the power 4 raised to the power 3 plus 2x to the power 3 raised to the power 4. Since there's one term combined by multiply, you can apply the exponent to the sign, to the number, to the letter. This is very important. You apply the exponent to the sign that is there, it's positive. You apply the exponent to the number that is there. 3 to the power 1 times 3 gives you 3 to the power 3. You apply the exponent to the letter with its exponent that is there. 4 times 3 gives you 12. There's a plus sign, meaning the plus separates this term and that one. You apply the exponent to the sign, to its number, you get 2 to the power 4, you apply it to the letter. X to the power 3 times 4 is 12. 3 to the power 3 is 27, it's x to the power 12. 2 to the power 4 is 16, it's x to the power 12. All over, that's 81, it's multiplied by 1 over 81 times x to the power 7. You simplify. You see there's like terms at the top. When there's like terms, guys, you can add and subtract like terms. You know, we learned that from earlier grades. When there's like terms are made of terms that are separated by plus and minus sign that have a same variable and the same exponent. So when we are adding like terms, we keep the jersey, the uniform. X to the power 12 stays like that. We add the coefficients, 27 plus 16, we get 43. Then the x to the power 12 stays like that. 81 times 1 over 81, we get 1. Okay, times x to the power 7. Then we can divide using S and L. Positive by positive, 43 divided by 1 is 43, x to the power 12 divided by x to the power 7. You keep the variable, you subtract the exponent, you get 43x to the power 5. Simple, nice, straightforward, and beautiful like that. Okay, I think next question coming up. 822a to the power 4 minus 3b to the power 3 raised to the power 2. Okay, 2a to the power 4 minus 3b to the power 3 all raised to the power 2. You look at this one, you look at the brackets, how many terms do you see inside the bracket? Hopefully you can see that inside the bracket there are 2 terms. My question to you, grade 11s, can I just take the exponent and distribute it to 2 and 4, distribute it to the sign, distribute it to 3 and b? Can I do that, seeing as though there are 2 terms inside the bracket? Remember here, in questions such as this, I could distribute the exponent to 3x and 4 because inside the bracket there was 1 term. I could distribute the exponent to the sign, number, letter because there was 1 term. And that's what I would get. 2 to the power 4 x to the power 12, 3 to the power 3 x to the power 12. I'm sure in situations and even in other situations that needed it, we did. Okay, we did it. There was an exponent inside. You could see there is a sign, number, letter, 1 term. We did it. We apply the even exponent to the negative sign, becomes positive. Apply the even exponent to the number, it becomes 2 to the power 2. Apply the even exponent to the letter, it becomes x to the power 6. My question is, we did it with 1 term. You see, apply the exponent to the sign, the number, the letter. We got 3 to the power 3, x to the power 3, which was 27, x to the power 3. Now we have a situation like this. There are 2 terms inside the bracket. Can we apply the exponent to the individual terms, or there is something else we need to be doing? 2a to the power 4 minus 3b to the power 3 squared. Do we apply the exponent just to the individual terms and say that's the answer? So in other words, do we say that this is 4a to the power 8 minus 9b to the power 6 plus 9b to the power 6, and that's it? Or is there another way? What do you guys say? What is the chat saying in the comment section? What do you say, chat? Oh, there's no one here. Sorry guys, I need to answer a call.